Hello friends, welcome to Engineering Funda family. In this video, I'll be going to explain you classful addressing of IP addresses. And before we start with this session, let us see how many things that I'm going to cover in this video. So first of all, I'll be explaining you how many basics are there with IP addresses. Then I'll explain you classful addressing of IP addresses, where we are having 5 classes: class A, class B, class C, class D, and class E. And after watching this, you will be having exact clarity regarding how all those classes are defined and how we can identify which IP address belongs to which class. After that, I'll explain you some interesting fundamentals in which I'll explain you how many number of hosts that is given in this given class of network. And along with that, I'll explain you how we can have network IP, and for that network IP, what will be broadcast IP address. And then I'll explain you how we can have unicasting and broadcasting, and that I'll explain you by practical examples. So let us see first how many basics are there with IP addresses. So in basics of IP addresses, I'll be discussing about IPv4 addresses. Here basically two types of IP addresses are there. One is IPv4 and second is IPv6. I'll be discussing about IPv4 addresses in this video. See, in IPv4 representation, it is having size of 32 bits and it is represented as per 8 bits dot 8 bits dot 8 bits dot 8 bits. 8 bits means 1 byte, or you can say 1 octave. So 4 octaves are there, and that representation as per octave dot octave dot octave dot octave. That is how it is there, right? And you should know 8 bit is having how much size? 2 to the power 8 means 256. So it is having range from 0 to 255. 256 means range is there from 0 to 255. So IPv4 IP address range that is there as per 0.0.0.0 to 255.255.255.255. And see, IP addresses that is organized as per hierarchical structure. In my previous video also I have discussed, right? Like, why do we need to have logical addressing? The reason is logical addressing is done with the use of IP address, and IP addresses that is having hierarchical structure. Like you see, it is defined as per class, and after class you need to go for network ID. From network ID you need to go for host ID. So whenever routing happens, at that time it will be having hierarchical structure. Like when we say we want to send something with respect to country, then after country there will be state, then city, then street, then society, and then your home number will come, right? So likewise in IP address there is a hierarchy. Like there will be one class. After class you will have to see what is network ID. After network ID you will have to see how host ID is there, right? So that is how hierarchical structure is there. So that hierarchical structure that I'm going to explain you by complete details along with classes. So let us see classful addressing of IP addresses. So in classful addressing of IP addresses, basically we are having 5 classes: class A, class B, class C, class D, and class E. First of all, I'll explain you how we can remember those classes. The reason is you'll have to understand that with respect to how IPs are there, as well as in examination you will have to remember like how those IPs are organized. So it is quite simple. You see, total bits are 32. And that is there as per 1 octave dot 1 octave dot 1 octave dot 1 octave. In total 4 octaves are there, right? So here with class A, first bit will be 0. With class B, first 2 bits that will be 10. With class C, first 3 bits that will be 110. With class D, first 4 bits that will be 1110. And with class E, first 4 bits that is 1111. See, that is how bit pattern is there. After that, you'll have to remember few basic things only, like network ID with class A that is there up to first octave. With class B, network ID is there up to second octave. With class C, network ID is there up to third octave. And with class D and class E, we are not having network ID and host ID, right? With class D, we are having multicast address, and class E that is reserved for future as well as for research. Now you need to understand this also. With class A, how many host IDs are there? So that is there as per 3 octaves. So last 3 octaves that is there with host ID for class A, With class B, last two octaves, that is therefore host ID, and with class C, last one octave, that is therefore host ID. See, this is how you can remember all the classes. Now let us discuss about how many basics are there with all the classes. Like you see here with class A, first bit that is 0, and then network ID is having 7 bits, and then host ID that will be having 3 octaves, means 24 bits, right? With class B, first two bits that is 1 0, and then up to second octave network ID is there. So 2 octave is having 16 bits. So 16 minus 2, that will be 14 bits with network ID with class B, and host ID is having 2 octaves, means 16 bits. With class C, first 3 bits that is 110, then up to third octave network ID is there. So 24 minus 3, that will be 21 bits of network ID, right? And host ID that is having 1 octave only, so 8 bits. With class D, in total 32 bits are there. Out of that, 4 bits that is 1110, those are first 4 bits, and then multicast address that will be having how many bits? 32 minus 4, that is 28 bits, right? And similarly with class E, first 4 bits are 1111, right? And reserved bits for future, that is having size of 28 bits. See, this is how number of bits that you can understand. Now there are few basic things that I would like to discuss about each and every class, right? Like when you talk about class A, then network ID is having how much size? You see 7 bits, right? And first bit is always 0. So what should be the range of class A? 0, then all 7 zeros. After that 0, then all 7 ones. So all 0 means 0, and 0 and then 7 ones means 127. So class A that is having first octave, that represents what? Network ID, right? And it is having minimum value 1. Why? The reason is all zeros are reserved, that is not given to any network, right? And all ones of network ID, that is also reserved, that is also not given to anyone. So instead of range that is there from 0 to 127, it is there from 1 to 126, right? 127 that is reserved. And by this pink color I am showing you this octave as per network ID. You see network ID is there for first octave. So first octave that is there from 1 to 126 with class A, right? In some books it may be written as per 127, but remember 127 that is reserved, that is not given to any network ID, right? Now when you say how many network IDs are there with class A, so this is how you should remember. See, 2 to the power 7 minus 2, so that is 126, right? 2 to the power 7, that is 128, minus 2, that is 126. So with class A, total network IDs, those are 126. Now let us see what is there with class B. See, in class B, first 2 bits that is 10. So obviously with this network ID, range will be from 14 zeros to 14 ones, right? I'm not writing it over here, you just understand that, right? And as if 1 0 and after that all zeros are there, then obviously what is that value for first octave? 1 and then 7 zeros, that will be 128. So first octave that is 128. But remember with class B, second octave that is also belong to network ID. So I am just marking it over here. So initial value that will be having range from 128.0.0.0, right? And final value will be there from first 2 bits 10 and then all ones are there. What it means? It will be 191, then 255, right? And then dot 255, dot 255. But you see this 255s that belongs to this 255 that belongs to host ID, right? So here, as if question is how many network ID is there with class B, then you can say it is 2 to the power 14, right? It is 2 to the power 14. Now with class C, if you observe first 3 bits that is 110. So obviously network ID that is there up to third octave. So based on that, you can say based on that first 3 octaves that belongs to network ID, and last octave that belongs to host ID, right? So here, what will be the range? See, 110 and then 5 zeros are there with first octave. So that is 192, right? And then 0.0, see, this 3 octaves that belongs to network ID over here, and last 0 that is there with respect to host ID, right? And it is ranging from 110 to all ones, right? Up to all ones it is ranging. So that will be 223.255.255 that belongs to network ID, and last 255 that belongs to host ID. So obviously here how many host IDs are possible with given network? 2 to the power 8, right? Now with class D, first 4 bits that is fixed 1110, right? And then multicast address bits will be there. It is having range from 224 to 239, and here with class E it is having first 4 bits that is 111, so it will be having range from 242 to 55. Now I'm not going to write all the network IPs over here with respect to bits. Why? The reason is, what I want is you just remember this IP addresses with respect to class A, B, C, D, E. See here, simply this is how you can remember. For class A, it ranges from 1 to 127. In some books, it is written up to 127, but 127 is reserved. So with class A, 1 to 127, this first octave that will tells everything. Second octave will be 128 to 191. Then class B is having 192 to 223. With class D, 224 to 239. With class E, 242 to 255. That is about first octave. And you should know, with class A, first octave only belongs to network ID. With class B, first and second octave that belongs to network ID. With class C, first, second and third octave that belongs to network IP, network ID, right? Or you can say network IP. So here, see, this is how we can remember all the classes, right? And here, this is what you will have to remember. The reason is, as being a computer science engineer, you will be finding many questions in many ways. So it is not like you will be calculating all those things as per this format, right? Directly you should know, like if it is having first octave that is there in between 1 to 127, then you can say it is there with respect to class A. If it is there in between 128 to 191, you can say it is there with respect to class B. If it is there in between 192 to 223, then it is there with respect to class C. If it is there in between 224 to 239, then it is there with respect to class D. If it is there from 240 to 255, then it is there with respect to class E. That is how you should remember. And see, with class A, first octave that belongs to network ID or network IP. With class B, first and second octave that belongs to network ID or network IP. And with class C, first, second and third octave that belongs to network IP. This is how you will have to remember the things. Now, very interesting part that I'm going to explain you now. So in that, I'll explain you how many number of hosts that is there in given class of network, as well as two very interesting things that I'm going to explain you. First is what is network IP, and second is what is broadcast IP, right? So with class A, we have seen first bit will be 0 and it is having IP address range from 1.0.0.0 to 127.255.255.255, right? But when it comes to network IP, then there are a few basic things that you should know. In network IP, first byte, or you can say first octave that belongs to network ID, right? So here, let me say it is 91, right? So first 91 that you will have to write, then dot 0.0.0. See this 0.0.0, right? That you will have to keep for network IP. So every network is having network IP, right? So see, network ID that is been defined by first octave, right? With class B, first 2 octaves, right? That is there for network ID, right? So as if I say I want to have one network IP for class B, then first octave that should be there in between 128 to 191, right? So let us say it is 155. So 155.4, see, this is what network ID for class B. Then dot 0 that you'll have to place for network IP. Like with class C, what is the range? 192 to 223. So when you talk about network IP, let us say one example, then you will have to take 3 octaves for network ID. So you see this 3 octaves, right? That belongs to network ID. So here in network ID, you see you can have in between 192 to 223. So let us say I'm taking 201, then dot 5, then dot 4. So this is what network ID, but dot 0 that represents network IP, right? So that is how network IP will be there. So remember here with class A, last 3 bits that should be 0 for network IP. With class B, last 2 octaves that should be 0, and with class C, last 1 octave that should be 0, right? So that is how network IP will be there with different class. This is just example. You can have any network IP, right? Now let me take one another case, which is broadcast IP, right? Which is broadcast IP. So with this given network IP, what will be broadcast IP? So 91.255.255.255, right? See, this is what broadcast IP for this given network IP. When you say class B, with that, as if you wanted to have broadcast IP, then what is that broadcast IP? This 155.4 that will be as it is. Then last 2 that should be 255.255, right? That will be broadcast IP of this given network. When it comes to class C, then what is the broadcast IP? Broadcast IP for this, this will be as it is. For network ID, it will be as it is, right? 201.5.4, but last should be 255. So see, network IP and broadcast IP that cannot be given to host. Remember this. As if with class A, last 3 octaves are 0, then it is network IP. If last 3 octaves are 255, then that is broadcast IP, right? With class B, if last 2 octaves are 0, that is network IP. With class B, if last 2 octaves are 255, then that will be broadcast IP. With class C, if last octave that is 0, then that is network IP. With class C, if last octave that is 255, then that will be broadcast IP, right? Now I'll explain you how many hosts that can be there with given network IP. So number of hosts with class A, that can be based on this many bits, right? So here we are having 3 octaves. So 2 to the power 3 octaves is having how many bits? 24. So 2 to the power 24 hosts. But see, out of 2 to the power 24, 2 IPs are reserved. One is for network IP and second is for broadcast IP, right? So minus 2 that you'll have to do, that will be number of hosts in given network IP, right? Now as if question is how many hosts are there in class B, then in class B how many hosts are possible? So host is having how many octaves? 2 octaves with class B. So 2 octaves means 2 to the power 16 hosts will be there, but out of that 2 IPs that is reserved for network IP and broadcast IP. So 2 to the power 16 minus 2, right? When it comes to class C, how many hosts are there? So number of hosts, that is based on 1 octave of host ID over here. So that will be 2 to the power 8 minus 2, right? So that is our number of hosts that we can identify for given class IP. Like one network is having how many hosts, that can be calculated as per this. So you should be having fair enough idea about, for any given network, there will be one network IP and there will be one broadcast IP, and those 2 IP addresses cannot be given to host, right? So how many hosts will be there? So with class A, we are having 3 octaves for host ID, so 2 to the power 24 minus 2. With class B, with given network, 2 octaves are there with the host ID, so 2 to the power 16 minus 2. With class C, we are having 1 octave for host. So 2 to the power 8 minus 2, right? So how it is coming? Based on network IP and broadcast IP, right? So now I think you are having exact clarity regarding how classes are there, right? So this is how classes are there, right? These are the basics that you need to understand, right? And based on that, now I'll give you few very practical case studies, like how we can have unicasting and broadcasting. So in unicasting, first of all, you should be having basic understanding, like what is unicasting. See, unicast means one-to-one message forwarding. So using IP of node, unicasting can be done. Let me take one example. Like here we are having one network and this is second network. Let us say this one network that is having one node over here and we are having second node over here, and we wanted to have transmission of data from 1 to 2. Then how this node number 1 will forward data to node number 2? So that will be done with the usage of IP of node 1. Now what could be the IP? IP of node 1 means IP of host. So that depends on network ID. Now here I have taken example of class A, in which class A is having first octave that represents network, and last three represents host, but 000 means this is network ID or network IP, right? So let us say this host number 1, is having IP that is 85 as per network ID. Then let us say it is 5.4.1. So that can be host ID in this given network, right, with host 1. Now similarly, as this host 1 is having this ID, with host 2 it will be having ID based on ID in network IP of this network 2. So you see, this is what class B type of network. How we can identify that? You see, first byte, that is 145. So that belongs to 128 to 192, means you can say this is class B type of network. And first two octaves, that represents network ID. After that you see 00 is there, means this is network ID of given network. Now with host 2, what can be IP? So first 2 bytes, that will be as it is 145.255, but last 2 octaves, that can be anything like 1.4, right? So that is how host 2 IP is there. Now simply when this host 1 wants to forward data to this host 2, then this host will be placing IP address, host 1 will be placing IP address of source and destination, and based on that, with this router it will forward data. And this router belongs to network 1, so it will be having network ID of this, and this router that belongs to class B with this network, right? So that will be having this ID. So first of all, it will take this message over here, and after that, based on host ID, it will forward it in this network, right? So one-to-one unicasting, that is how it is happening. So based on network ID and network ID, means network ID will define network IP, right? As in class A, first byte that defines network ID, and based on that, network IP will be there. In network IP there will be 0.0.0. With class B, first 2 octaves will define network ID, and based on that, network IP will be there, in which last 2 octaves will be 00, right? Now let me explain you broadcast. Broadcast is quite interesting. See, there are 2 categories of broadcast: limited and direct. So in limited broadcast, what we need to do is, in limited broadcast, we can broadcast in given network. For example, as if I say this node wants to broadcast message, right? This node wants to broadcast message. Then this node will have to use this IP. If this node is using 255.255.255.255, then you can say this node is broadcasting message in this network. So in this entire network 1, it will be broadcasting message, that is limited broadcast, right? Now as if we want to do direct broadcast, then see, direct broadcast can be done from one network to another network. For example, as if I say, here we are having one node. Now if this node wants to do broadcast in this network, then this node will do what? This node will use IP of this network. So as if this node wants to broadcast message everywhere over here, right? Then this node will be using which IP of this network. See, first will be network ID, that is 85, then dot 255.255.255. See, this is what broadcast IP for this network. So this node will be using this IP address, and when it forwards this frame via this router to this router will broadcast this message in this entire network, right? Similarly, as if this node wants to broadcast message in this entire network, then it will be using, see, this class B type of network, in which 145.25.255.255, that IP, that will be used by any of this node to broadcast message in this network. Simply, this is how we are doing broadcasting, right? Now I think you are having fair enough idea about how IP addresses are there, how classful addressing is happening, right? And if still anything that you would like to share, please note it down. And we are doing so much hard work, so I would like to have your support, and for that I request you to do sharing of these videos with your colleagues. Definitely that will help us even. Thank you so much for watching.